Okay, guys, I'm going to do a couple of similar triangle proofs for you guys so you can see how they work. With similar triangles, again, there's three different things they could ask you to prove for similar triangles. So depending on what they ask you to prove, you kind of know exactly the way your proof ends. Okay, so first things first is the only way to prove triangles similar is AA. That's it. One way is all you have to remember. So the first example I want to do is on page 22. It's number 3. And you're being asked to just prove triangle FDC, that's this one right here, is similar to triangle EBC. Okay? So again, all you have to do is prove that they have two angles the same. Well, the first thing you notice is you're given parallelogram. So if you're given parallelogram, you're thinking of all the properties of a parallelogram you could use. But again, it's really properties about angles since these are only proofs about angles. So the first thing I could say using that parallelogram is that angle B is congruent to angle D. I know that opposite angles of a parallelogram are congruent. Then I'm also given that CE is perpendicular to EB, so I could mark a right angle there. And I'm also given, which I forgot to write down here, is that CF is perpendicular to AD. So I also know we have another right angle right here. Again, I can mark both sides, but that's the angle I really need. So based on my markings, I know I have two similar triangles because I have two congruent angles. So the proof is fairly simple, right? We're just going to start with our givens, which I'm not going to rewrite to save time, okay? Doesn't matter what order I say them in. If I start with these angles, I don't need to number these because I can name them angle B and angle D because there's only one angle there. And again, that's because opposite angles are congruent in a p-gram. Okay, now as far as the right angles go, again, I'm going to number these because otherwise I would have to name them with 3 letters. Again, I can jump right to angle 1 is congruent to angle 2 if I say in my reason perpendicular lines form congruent right angles. So now that I have those two sets of angles, I am done with my proof. I can say they are similar. Again, the symbol for similar is just one squiggly. And my only reason to ever prove similar is going to be AA. Bam, proof done, okay? All right, the next one I want to do is where you could have an extra step after you do this, okay? And that would be if like page 23, number 2, okay? So in page 23, number 2, you're being asked to prove a proportion. Okay, so if you're being asked to prove a proportion, you know you still have to prove two triangles similar first, okay? So again, we'll start with our givens. So I know I still need to prove these two triangles. Now again, there's only 2 triangles in the picture, so I know which triangles they are. But again, if there were multiple ones in the pictures, you just look at the sides they're talking about in the proportion. They're talking about AB, ED, AC, and EC. So again, there's 2 sides in this triangle, 2 sides in this triangle, so you know it's these 2 triangles you're trying to prove. Again, with this one, you could prove all 3 angles are congruent, so just pick any 2. Lots of times people see the vertical angles and just want to start with those vertical angles, so I'll do that. I could say angle 1 is congruent to angle 2 because vertical angles are congruent. And then the next set of the angles I'm going to get off of the given because I'm given AB is parallel to DE, which again, anytime I see parallel, I should be looking for alternate interior angles. So I could say B is congruent to D. Or I could say A is congruent to E. It doesn't matter which one I say because again, the parallel, remember the Z goes forwards and backwards, so both of those would be congruent, okay? And again, that would be parallel lines cut by a transversal form congruent alt interior angles, okay? Now, what I could have done too is, do you see if I said both sets of alternate interior, I could have left off the vertical angles altogether, so it wouldn't matter. Okay, so again, once I have AA, I don't know that I have a proportion yet. All I know is I have two similar triangles. So the triangles that are similar are ABC. Okay, technically you should state them similar in the way they're similar. So because E is congruent to A, I should put the E where I have the A. B is congruent to D, I should put the D here, and then C. Okay? But again, I know this from the algebra. Once I know triangles are similar, I can set up a proportion between any two sets of sides. The two sets of sides I want to set up the proportion with are the two sets of sides I'm proving. So I know I could set up a proportion that says AB corresponds to ED, where AC corresponds to EC. So all I have to do is just state the proportion they wanted me to prove. The reason why I know these sides are in proportion is because I know the triangles are similar, and similar triangles have proportional sides. So the statement that can kind of sum it up is what we say is corresponding sides of similar triangles are in proportion, which we can abbreviate CSSTP. So again, anytime you see a proportion as you prove, you know your final statement is CSSTP. But what you also know with that is the step before it has to be AA. So you kind of know the last two steps of your proof just based on the proof, okay? Now, the third situation they're gonna give you is kind of like page 25, number 5, okay? So they're being asked you to prove this product, that MN times LJ is equal to JK times LN. Okay, so when they ask you to prove a product, right, what they're being asked you to prove is the cross product, the products you get when you cross multiply. So again, if we work it backwards, again, you can only cross multiply when you have a proportion. But you only have a proportion when you have similar triangles. So with this type of proof, technically I know what the last 3 steps of this proof are, right? So I know I have this step because the product of the means has to equal the product of the extremes. That's just the fancy names for the cross multiplying. But before that, I know I have to have a proportion, which is always CSSTP. But before a proportion, I always have to have AA. And similar triangles. So I actually already know the last 3 steps of this proof before I even look at what I'm given, okay? But again, doesn't matter what I'm being asked to prove. I know I'm first gonna have to prove them similar with AA, right? So if we look at what we're given that this is a trapezoid, that JKNM is a trapezoid. Again, not an isosceles trapezoid, just a regular trapezoid. So if you remember, the only properties a regular trapezoid has is that the bases are parallel. So that's all I know. So basically, I know I have parallel lines. But where there's parallel lines, there's angle pairs. The angle pairs could either be most common alternate interior, second most common corresponding. Now what this one is, do you see the only 2 triangles in this picture are this top little guy and the big guy, right? And then here, I got the top guy and I got this big guy, okay? So for this, there's no alternate interior in this picture, so this is going to be a corresponding situation. Now, same as before, there's a way to prove all 3 angles congruent, so you just pick any 2 you want. First thing, whenever you see a triangle inside another triangle, you should always be looking for a shared angle. Do we see that they share angle L? They both have angle L. So if you want, you could say angle L is congruent to angle L. And that would just be reflexive. Still the same reflexive we've been using all along, okay? Now the other 2, again, worst case scenario you can't figure out, you can't get the second set of angles, no big deal. Just skip that step and then go to AA so that you could at least finish the remaining 3 steps. But the angles we're actually going to use here are corresponding angles. So remember, corresponding angles are same spot angles. So in the parallel lines, this one is top left, this one is top right, top left, however you think about it, but these are in the same spot. Again, I'm gonna number these because I cannot name them with just one letter, okay? So what I'm gonna say is that angle 1 is congruent to angle 2, or I could have said, because it's also true that these two and these two would be congruent. So if I number those 3 and 4, I could also say that angle 3 is congruent to angle 4. Either set, if you say both, then you don't have to say the reflexive because you only need 2 A's. So this is parallel lines cut by a transversal form congruent corresponding angles. Okay, so once I know I have AA, whichever form I did, I'm going to say the triangles are similar. So I'll start with the little guy. It's triangle LMN is similar to triangle, if I go in the same order, it's LJK. Again, the reason for similar is always AA. I know after AA, I can always state the proportion, right? And I know the proportions reason is always going to be CSSTP. So you say, well, what proportion is it? Like how would I set up the sides? Well, here's the thing. All you really have to do is go back up to your prove and undo the cross multiplying. If MN is multiplying LJ, that means MN and LJ have to be on one of the diagonals. JK and LM are on the other diagonal. It doesn't matter what order you put them in. JK, LM, you could switch it up as long as you just uncross multiply, basically. Throw them on the diagonal, and that's what the proportion is. And then finally, you know MN times LJ, because if you have a proportion, you can always cross multiply and say these are equal because in a proportion, the product of the means equals the product of the extremes. You'll see in the packet, I abbreviate it lots of times, POM equals PO. That's fine. On a Regents, you probably want to write out the words means and extremes. Okay? All right, let's just try one more.